Hello, my friend. Today we are doing alpha mirror. Basically, we have to write a program called alpha mirror that takes a string and displays the string after replacing each alphabetical character by the opposite alphabetical character, followed by a new line. So basically, A becomes Z and Z becomes A. Case is not changed. If the number of arguments is not 1, display only a new line. So we open our terminal, command space, iterm, I cd inside my desktop, and I create my exercise that I simply call main.c. main.c. For this specific exercise, like always, I can only use the write system call. So I will only include my Unix std.h. Then as always, the usual boilerplate, basically my main function that takes integer argument counter and a char start argument vector. These are the command line arguments. Here I have the number of arguments given at the command line level, and here I have the strings which have been given at the command line level. Perfect. I complete this boilerplate with the return 0. This is the return value to state that everything has been correct, and now we are ready to fill the main function. At the bottom I have if the number of arguments is not 1, display only a new line. So here I can simply say immediately if 2 is equal argument counter, I perform my algorithm, right? This is where it's gonna be performed all the code. Basically only in the case I have 2 at the argument counter. I recall to you that I need the 2 here because this argument counter is taking into the account also the path toward the program. In every other case, what do? Well, I just simply need to write, I need to flush in the standard output a new line. So I'm gonna use the write function. Write in the standard output, so 1, a new line. So basically here I have a string with the double quotes, \n, and here I have 1 for 1 byte, right? Semicolon, perfect. So basically we can short here, and now I'm ready to fill my algorithm. So basically I have to take the string which is in position 1, right? Basically argument vector in position 1. Now to make it easy to read the code, it's far better to do this. Here I define a new string, so char star s1, for example, and I say s1 is equal to argument vector in position 1. Okay, doing like that is very easy to manipulate this string s1, right? We don't have to deal with double pointers. And I recall to you that it is very important to write code such that other people will be able to read it, and even yourself will have to be able to read your own code, because believe me, you won't be able at times to even recall what you wrote. So here I'm gonna manipulate s1. So basically now I have to loop inside the string searching for alphabetical chars, right? So I'm gonna do while at s1, so until I have a char inside my string, right? Here to write different from 0 is redundant, because I'm gonna use the sentinel value 0 at the bottom of the string as a Boolean value, so I can basically forget about that. Okay, so ask open, and I'm gonna open this block, make this smaller to see better. Okay, now what I'm gonna do, well, first of all I have to make sure that the char pointed by s1 is an alphabetical char, because you know perfectly well that I have a plethora of chars, not only the ones coming from alphabet. So I say if is alpha, which is a function that I'm gonna create that takes as an input a char, so at s, right? So this function is going to return me a Boolean value, true or false, if the char is an alphabetical one. So ask open another block. Now inside this block, I am sure that I'm dealing with an alphabetical char. The challenge wants that the case is not changed. So if I have an uppercase A, I need an uppercase Z, right? As well, if I have a lowercase a, I need a lowercase z. Easy. So inside this block, I know that I have an alpha, but also I need to check if the char is uppercase or lowercase, right? So I'm gonna do another if-else statement. Okay? So I'm gonna do if is upper, another function that I'm gonna implement at s, ask open, curly braces. Here I say else if is lower, and then as well the char. But what do you think about this is lower? Is it necessary? Well, we already know that we are inside a block that contains only alphabetical chars. So or the chars are upper or the chars are lower. So I don't really need to check for this function, right? Because we have a binary state if you want, or upper or lower. So I can basically discard this piece of code and I can only leave the else. Else, you do something else, right? Here I'm gonna write the code for the lower chars. Cool, let's make it short. So here I have this big block that contains all the code in the case that the char pointed by S is an alphabetical char. Here, on the contrary, I put everything else, right? I put else, every other char, which is not an alphabetical one, upper or lowercase, I'm just gonna write it. So write in the standard output, so 1. Here I need a pointer, so I'm gonna give directly S1, which is a pointer, it is an address, and only one byte. That's it. And then, of course, I have to increment the pointer itself as 1, so plus plus S1, semicolon. Here it comes. That's the blueprint of my little algorithm, as you can see. I'm gonna enter this block only if I have one string as an input at the command line level, thanks to this Boolean expression. I'm gonna iterate all the string, right, while S1 until I don't reach the sentinel value 0 at the bottom of the string. And I'm gonna check if I have an alphabetical char, and if it is upper, you do something, otherwise you do something else you just write the char, and then you just increase S1. Cool, now we're gonna implement isAlpha and isUpper. So we go above the main function, and given that we are using Boolean values, why not including the standard Boolean, right? So I can use directly Boolean false and true, which is more elegant, more readable, even though I can use directly integers. So let's make the isAlpha function. I do bool, which is the return value, isAlpha, which takes as an input a char that I call C. Okay, let's make it bigger now. So what is the idea of isAlpha? Well, it's very simple, right? The char has to be in a specific range to be considered an alphabetical one. What do I mean? Well, just look at the ASCII table. You just do man ASCII, and you just watch for the decimal set. As you can see, I have 128 chars in the ASCII set. The alphabetical ones range from 65 to 90 for the upper cases, and for the lower cases, we go from 97 to 122, right? So to check if a char is an alphabetical one, you just need to say, hey, is this char in those ranges? So let's do that. I'm gonna say if C major equal, then what? Major equal, then 65 or A. Here I can write directly 65, or I can write A. It is totally equal, so we're gonna mix the two so you can understand that that's really the same thing. And C minor equal, then 90. 90 is Z, just the char before the square bracket. And, right, another condition I have to check for lower cases. When I have an end, I really like to do something like that, to go on the next line. So I can very easily see all the expressions, all the Boolean expressions. And open braces, C major equal, then A, which is 97, and C minor equal, then Z, or 122. If I get this condition, if this is true, if the char is either in these two ranges, what do? Ask open, return true, right? Semicolon. On the contrary, you just return what? Return false. Here it comes. So this is my isAlpha function. Cool. Now let's make the isUpper case. So Boolean again is upper. Here, if you want to center the image in Vim, you just do ask ZZ, and then you open the braces, and again, you get a char C. Open curly braces. Here, my friend, that's the same idea, right? You say if C major equal, then A, and C minor equal, then Z. Return true, return false. Okay. As you can see here, I don't need to use the else statement, right? Because if this condition was true, I would have been already exited at this level. So I don't really need to put an else here, right? Like that. This is redundant. It's not necessary. So I'm gonna delete it, and here we are. So I can save. So cool. Now I have my two functions, which are implemented, isAlpha, isUpper. So now let's go back to my main function. Now we have to understand what operation I have to do at this level. So I have to make a mirror. Basically, if I get a lowercase a, I want the lowercase z. First of all, I'm going to write the code, and then I'm going to explain what I'm doing. So given that I'm using the right function, I want to have a variable here that is a char. So char c, semicolon. And here I do something peculiar. I say c, so the char, in the case the char pointed by s is upper, what do? Is equal to what? Is equal to look carefully now. I have 65 plus 90 minus at s. Okay, so this is the expression I want to use. I will explain immediately. And then I just simply write this one. Okay, write in the standard output the address of C. As you can see now you understand why it's really useful to have a char here, because I need a pointer to that. And then just simply 1. Cool. Here, on the contrary, I say C is equal to, this time I'm going to use the chars. So A plus lowercase z minus at s. So the same, basically, but here is not s, it's s1. Better if I change it here. So this is called refactoring the code, by the way. And it is a pain in the ass. All right, let's change it here. S1, S1. Okay, so here I just rewrite the char. Okay, so I'm going to copy paste. And I think it's ready. The code is ready. Now let's try to launch it initially, and then I'm going to explain everything. So ZZ to exit. So compile and launch with an input like hello. And there is, of course, a mistake. I made a silly mistake, probably, at the logic level. Let's check quickly here, since everything is correct. And that's correct. So here it comes. Here it comes, the stupid mistake. Here I have an AND logic, which is not possible, because or I have the char in this range, or I have the char in this other range. All right, let's retry. So compile and launch hello. Seems like S wall. A, it should output Z. Cool. A, B, Z, Y. Perfect. A, B, C, D, A. Okay, this is the alphabet in reverse. And A, Z has to be Z, A. Okay, allegedly, it seems to work everything correctly. Now, let's try to understand better this code. The main function is kind of simple, right? Here, I just declare a string in which I assign the first string in the argument vector because it is easier to read. That's the only reason. Then I say if true equal argument counter, I just invert the true and the argument counter because it is super easy to make this kind of mistake. For example, AC is equal to 2, but this is an assignment which is legal. So inverting the number, the constant, and the symbol here makes the code overall more robust. And this is a good habit to acquire. Okay, there's the same, right? So you can invert, they are the same logic. And I just loop inside my string and I say, okay, if I stumble upon an alphabetical one, I have to check if this is upper or this is lower. And then I just have this expression, which is the tricky one in my opinion. And now we're going to understand. 65 plus 90. Of course, you perfectly understand that 65 is simply A and 90 is Z, right? As you can see here, 90 and 65. So to understand this point, I prepared just these simple slides. So it's going to become an ice cream vanilla to understand what is going on. You know from the ASCII table that every number has a specific char linked. For example, 97 is lowercase a. I repeat this stuff ad nauseum, right? For this specific exercise, I want that if I stumble upon A, I want Z. If I stumble upon C, I want X. If I stumble upon M, I want N, all right? So I need a strategy to get this algorithm to work out. Let's decompose this problem. My idea is to sum A and Z. When I say sum A and Z, you perfectly know that I'm saying sum 97 and 122. The sum of the two is giving rise to 290. Perfect. So I have this value. What is this value about? Check carefully now. If I say 219 minus Z, what do I get? Z is 122, right? I get that on A, right? Which is 97. So I think that it's kind of tricky to understand this point. So let's visualize this problem in another way. Let's pretend we have another ASCII code. This time we have the lowercase a that starts from 0 and Z, it's 25. Very, very simple. Now let's repeat the operation. A plus Z, which before was 97 plus 122. Now it's becoming 0 plus 25. 0 is A, 25 is Z. Okay? This is fake, of course, for the sake of argument. So now the value that I'm gonna use is 25. 25. And not anymore that 200 and something, which is confusing. So now I'm going to say 25 minus Z. Let's pretend I stumbled upon the char Z in my string. For the exercise, I want the letter A, right? So here I say 25 minus Z, the letter which is pointed. What do I get? Well, I get 0, right? 25 minus 25 is 0. That in my fake ASCII code is A. On the other hand, if I stumble upon the letter A, this time I want Z. So I say 25 minus A, which is, of course, Z, right? 25 minus 0. So you see how I exploit the value of a specific char to get my final result, to get my opposite algorithm to work out. Basically, I take the value of the biggest char in my alphabet, in this case is 25, and I use it as a pivot. I'm going to use it to derive my value. I say, if I stumble upon z, I want to remove z to the biggest, so it's going to be the 0 at the beginning. On the contrary, if I stumble upon a, I'm going to remove 0 to 25. I think you have to spend a little bit of time to understand the best way you can this idea, and basically that's it for this exercise. As you can see, this is the formula I'm using. Of course, I have to use the real values. I cannot use the fake ASCII. So basically, I'm going to sum the values of the specific chars, and then I'm going to subtract the char pointed. This allows me to get the specular one. Now, regarding the two functions, is alpha and is upper, we can do them better. I can do something like that. I can simply say here, return this, like that. You can see the function now is not written very clearly, but it's gonna return true if this is true, otherwise it's gonna return false. So I can do the same even here. Basically, the functions are gonna become one-liner, and here we are. Now, of course, the problem here is that I need to add a semicolon. Single statement is not anymore boolean condition and if save. Okay, let's go out, compile and launch ZA, of course. All right, it seems that the code is working properly. Perfect. So this is the code in all its beauty. Camel to snake. We have to write a program that takes a single string in lower camel case and converts it to a string in snake case format. So basically is this stuff here, right? We also have the kebab case, I didn't know. So snake case, camel case, because we have this way of writing, and the kebab case. Perfect. We want to go from this to that. So I can exploit the upper char as a sentinel value, right? I'm gonna iterate inside the string, and when I stumble upon an uppercase, I'm gonna say, hey, here I need to change. I need to write an underscore, and I have to change the C in a lowercase c. So command space iterm cd desktop and vim main.c. As usual, I'm gonna include the Unix standard to use the write function, and then my boilerplate int main int argument counter char star argument vector. Okay, and the return 0 to be super pedantic. I'm gonna handle only one string at the command line level, so I'm gonna do if true is equal to argument counter. This is the only thing I'm gonna do, otherwise I'm gonna just write the standard output a new line. Okay, so 1, and then I just return. Okay, in the case I have my string and everything seems correct, I'm gonna do, first of all, I'm gonna assign to a new string. Okay, so pointer s, declaration of the pointer, and s is equal to argument vector in position 1. This is gonna be super useful to make the code more readable. Then I say while what? While at s. Okay, ask open. So the condition is while I have a char which is different from 0. What do? Well, if the char pointed, right, is in uppercase. So here I can call the is upper function that I can create, but it's so short that I can do immediately here. So I say at s major equal a and at s minor equal z. So here is simply written is the char in uppercase. What do? Well, ask open. In this case, you have to write an underscore, right? Because we want to perform a snake type of typing, right? So I'm going to write in the standard output a string constant, which is an underscore, and then of course only 1 byte from that string, semicolon. And then I want to write the char, but in lowercase, right? So what do? I just say I create here a variable, which is char c, okay? And here I assign to the variable c is equal to the char pointed by s, which is in uppercase. How do I invert a char from uppercase to lowercase? Well, it's very simple, right, my friend? Here I have 65. If I want to have the lowercase a, I just need 97. 65 to 97, I just need to add 32. So to toggle between uppercase and lowercase, I just need to add 32 to the value. Here I say at s plus 32. Super easy. Now I just have to write in the standard output this char, so 1% c, and then 1. Okay. Hey, if you stumble upon a char which is in uppercase, you just write an underscore, then you invert the char. Basically, you you assign the value of the respective lowercase char to see, and then you just write it. Okay, easy. Else, what do? Well, else you just write what you stumbled upon. So you just write in the standard output. Here I need a pointer, so I'm gonna give directly s and then 1. Okay, bottom I just need to increase s with pointer arithmetic. So every time s is pointing to the next char. What do you think? I think we have already finished with this algorithm. Let's try to launch and check for eventual bugs. So it's easy. Compile and launch with the camel case. Launch. You can see here I have achieved the conversion into the snake case, right? Let's try with an empty input. Have a new line. Something without an upper letter work. Any upper case. You can see I have this big boy. All right, everything seems to work correctly. All right, now we have to write the atoi function. Basically, this is a function that takes a string and converts it to an integer. So inside my terminal, cd desktop and vim main.c. Of course, I give the name main, but I can give whatever name I want. Basically, atoi.c would make much more sense. As usual, I'm gonna include this time the standard input output. I want to use the printf, and here I have my main. So main int argument counter char star argument vector. Okay, boilerplate return 0. Boom. Here we are. Now here I have to implement the atoi function that now we're gonna check together. Just simply open another page, the terminal. Then I type man 3 atoi. Okay. You can see I got into the manual and I can check what this atoi is all about. Immediately I see that this function is returning an integer and takes as an input a const char star string. Okay, so it's taking a pointer constant. So basically, when a function is called with the constant keyword, it simply means that the function won't change anything about the string because it simply can't. Okay, so I'm sure that when the function returns, it hasn't messed up with my string. So long story short, the atoi function converts the initial portion of the string pointed by str to int representation. Initial portion, I will explain to you what it means. Okay, we are ready. So we have an int my atoi, okay, and as an input I have a const char star str. Here you can read like that. This str is a pointer to a char which is constant. As you can see, we go from right to left. Okay, I cannot go to the right here from the identifier, so I have to go to the left. So from here, I go there and then I go there. Okay, ask open, and now we're gonna implement this function. Here at the main, I simply say printf %d n with the original one, so atoi. To use the atoi, I need to include the standard library. So I'm gonna do that, include standard library. So here I have the atoi function now that is available, and I give as an input argument vector in position 1. Perfect. I just copy this line, so yy and then p fast, and I'm gonna do my atoi, okay, with the same input, which is argument vector in position 1. I can write real atoi. Here I write fake. Of course, I have the conversion specifier, which is d, because the atoi is returning me back an integer. Okay, we are ready to rumble. Let's implement the atoi. Of course, I'm going to need a container, a variable, where I will stock my number. Of course, the function is returning back an integer, so I'm going to have integer and b, okay, or simply n. Of course, I have to assign the value 0, otherwise there will be junk inside this variable. Then the number can be negative, of course, right? So I have to say if at str, so the char pointed by str is equal to minus, right? The char minus, what do? Ask open. I have to remember the sign of this number. So I need a flag, I need a variable flag that I'm gonna create immediately. An integer, can I call sign, okay? Initially, the sign is gonna be positive, so I say +1. Of course, the plus is redundant, but to make extremely clear to the reader that this is for that specific sake, to show that the number is positive. On the contrary, if the number has this negative sign, I'm gonna say here, sign is equal to -1. So initially, I assume that the value is positive, and then I simply check if the first char is minus, so the number is negative. So the sign is equal to -1, and then I just simply increase str. Of course, I have to skip right this minus. Semicolon. Cool. I won't take into account the plus sign because It's never used, but it's fairly simple to add code to handle even the plus sign just in case. So now what do? I have to say, if the char pointed by str is a number, but not a number in the sense of an integer, is a symbol representing a number. So basically, if the char pointed by str is one of these ones, okay, from 48 to 57. So what do? You know perfectly well. I say if at str is major or equal, then what? Then 48 or then 0. Let's make it, it's more readable. And at str is minor or equal, then 9, right? Scopen. Here I have a symbol representing an integer. So I have to add to my number. N is equal to what? Well, of course, I need to add the value represented by the symbol. So for example, if the char pointed is the symbol 9, it has the value, the real value, which is 57. So to convert this 57 to the integer value itself, I need to subtract this value 48. Do you understand this point? If I make 57 minus 48, I get 9, of course. So I use the 0 as a pivot value to derive all my real values of the symbols. So to convert the symbol, I say at str minus 0 or minus 48, okay? So it's fairly simple if you think about that. Try to think about this operation. Here, let's make 48, so it's super clear that it is just a subtraction of numbers. Indeed, chars are just 1 byte integers underneath the hood. That's all there is. So here, if I have the symbol 9, which is 57 minus 48 equal 9. Easy. Now, we're not finished, right? I cannot do that, first of all, only one time. This is not correct, right? Here I need a while loop, not only an if. So while until I stumble upon a symbol which represents an integer, I need to keep going on. But every time I cannot just assign this value. I need an operation that allows me every time to add the value and then shift it one position. Given that we are dealing with decimal numbers, to shift one digit, it's fairly simple. I just need to multiply the number per 10, right? If I have 5 and I want to shift one position, 5 per 10, 50. Per 100, 500. Per 1000, 5000. Easy, right? I'm shifting one position, that specific value. So I say n is equal every time to n per 10, right? Every time I'm shifting one position, initially n is equal to 0. So this at the very first iteration is influential, and per 10 is going to be 0. So 0 plus the value of the char pointed. So every time I have one char that is pointing, I derive the real value of that char and I add to n. At every iteration, I'm going to increase, so every time I get one shift, okay? Here I just simply write shift one position, okay? And this one is convert to real value. That's what it is. And then very simply, I have to increase by 1 str, right? We have pointer arithmetic as always. So until I have a char pointed by str, which is a symbol representing an integer, you do this operation. Shift, add, shift, add, shift, add, okay? Here, when I say shift, of course, I don't imply the shift operator, which is this one in C, right? We have also these operators that are called shift, but this is totally another thing. I'm talking about, you understand what I'm saying, right, in this point. Well, then we are finished, right? I'm going to return what? I'm going to return the number per the sign, which we have stocked inside this flag variable that we have set up in these specific points, okay? That's all there is. Now let's try the algorithm if it works. It's easy. I'm going to compile and then just launch for minus 4. Okay, it seems to work. Try with 0. Let's try with the biggest integer, which is tube builder. 37, 48, 36, 38 works. Let's add 1. Of course, I have the overflow, and the atoi, even the real one, is not handling properly the overflow. Of course, this is too big to fit inside a signed integer, so I get into the other representation, the negative representation. Then when I say that the atoi is handling the first portion of the string, like here, you see, the initial portion of the string, simply means that here, for example, if I have this gibberish, the atoi doesn't care, right? It's taking care only of this point. That's why here I have this condition. I only care until I have symbols representing an integer value. After that, the while is okay, and I am gonna simply return the value for the sign. Okay, that's it for the atoi. So we have to do a program that takes 3 strings. Basically, these 3 strings are 2 numbers and 1 operator. And the program has simply to display the result of this operation. Let's understand practically how this program works. So cd in the desktop and create my main.c. Perfect. I'm going to include the standard input output and the usual boilerplate. So int argument counter char star argument vector. Okay, and then the return 0. Now this program is going to work only if the inputs coming from the command line are 3, basically 2 numbers and 1 operator. So I need to make if 4 is equal to argument counter, of course 4 because 1 is for the path of the program. So ask open comes, otherwise we are just gonna write a new line. Okay, so printf \n, and that's it. Now if we have 3 strings, what do we do? Now for this specific exercise, I think it's pretty useful to use the switch operator. If you don't know how it works, just check it out, it's fairly simple. I'm gonna have as a input something like that, for example a.out, and then I have 32 plus 15, right? Here I can have plus, minus, divided, modulo, and multiplication, right? I can have all of them. So I can make a switch case checking for this specific char, and given that specific char, I will perform the real mathematical operation. So to make a switch, I do switch, okay, and then an expression, which is argument vector in position 2, right? Because I have the path, then I have the first string, and then I have the operator. So in position 2, 0, 1, 2. The first char, of course, the one in position 0. So this is the expression. And then I have all the cases, right? That's why I think the switch is pretty cool. I say case, the char is a plus. So I say case plus, colon. What do I do in the case it is a plus? Well, I need to add the first string and the third, right? The first and the third. So I need the atoi function because all the elements coming from the command line are strings. So I'm going to include the standard library, include stdlib, okay? So I can use the atoi function coming from the library without having to implement myself. So in this case, what you do, printf, the result is %d, new line, and you do atoi of what? Of argument vector in position 1 plus atoi argument vector in position 3. That's it. So this is gonna print the result of the real operation, because the atoi is gonna convert the string into a number. Then I have the real plus here, given the case, and that's it. Fairly simple. Then I just need to break, because every time I enter inside that one specific case, I need to break in the switch. Otherwise, this is not like the if else. All the beneath cases are gonna be performed. That's why every time I need the break. So I say case minus, and you basically understood all the algorithm, right? Now it's the tedious part that you have to fill with all these cases. So very shortly, I'm gonna write everything, of course, copying past the hell out of this code. So break. Here I just need to change to minus. Then in the case I have a modulo colon. I'm gonna copy this code, a modulo here, then just a break. Case divisor. Okay, here it comes. We call it right. Here I forgot the brace. Every time this tedious tactic mistakes. Okay, here we are. So break, and then finally the multiplication. Case multiplication. You just do that, and then you break. All right. Then I have the final case, which is like the else in the if else statement almost, and it's the default one. So default, you just what happened? Just printf a wrong operator, dude. Line. All right, we are here. We are done. So this is all the code in all its glory. Now we're gonna try to launch and find eventual bugs. So compilation and launch with 32 plus 5. Mistake. Mistake in line 23, position 59. Let's check it out. What happened? I need the curl. I need a round brace here. Okay, let's try again. The result is 37. Another problem is that it's writing me a new line, and though I don't want to. So here, of course, I have to insert an else. All right. Now let's relaunch again. The result is 37. Perfect. Modulo 5. The result is 2 divided 5. The result is 6. All right, you understand how it works, right? Of course, it's not taking care of the overflow, you see. Anyway, you understand the point, right? You can add all the code to handle eventual overflows and so forth, but this is the core idea, right? The switch case, I think in this case is pretty fucking useful. So overall, I don't suggest it, but here it's kind of neat. What do you think? All right, we are done with this function. Okay, we have to make a program, takes 2 strings and displays without doubles the characters that appear in both strings. So as usual, vim main.c. I'm going to include my standard to use the right function. Here I have the main function in int argument counter char star argument vector and the return at the bottom, which is not necessary though. So this time I'm not gonna use it. So the program is gonna work only if the inputs coming from the command line are 3, right? I want path of the program and 2 strings. So if 3 is equal to argument counter, ask open, I do the action. Otherwise, I just simply write in the standard output a new line, so 1. Okay, of course here I have to add the else. All right, in the case we have our strings, what do we do? Well, here of course I need a nested while loop because I have to check for every char in the first string if there is a matching char in the other string. So every time I'm gonna loop inside the string s1, for example, and every time I'm gonna check all the chars in string 2. So I need an iterator that every time is gonna be refreshed to 0 to restart the second iteration. So to make the code more readable, initially I'm gonna do char s1 and char s2. Okay, so s1 is equal to argument vector in position 1. Okay, and s2 is equal to argument vector position 2. This is just stuff to make easier to work. And I need a nested while loop. So I do while at s1 until I have a char which is different from the \0, right? The sentinel value terminating the string. Ask open, what do I do? I need another while loop, so I say while at s2, right? As well. But this is not totally correct, because every time I need to restart the string s2. So here I'm gonna create an iterator. I'm gonna create an iterator up here, so int, classic name for an iterator is I, okay? I, and assign to I the value 0, otherwise they're gonna be garbage inside this variable. And here I say while s2 in position I, using the square bracket to make it super simple, even though this is just syntactic vanilla. Oh, syntactic sugar, sorry. Syntactic vanilla. Ask open, here I wrote 1, not I, mistake. So I has to be refreshed every time. So I need to assign the value to I, not exactly here, but here, right? I is equal to 0. Because every time, at every loop, at every external loop, I has to start to the beginning, all the time like that. Nice. Here, of course, I don't need an index because I'm going to exploit directly the s1, given that I don't need to go back, like in the case of s2. So initially, I'm going to do a naive implementation to understand better some ideas. So the naive implementation is this. I say if at s1 is equal to s2 in position I, what do? Ask open, you have to write this char, right? You just write in the standard output this char, so I use s1, okay? So 1 byte from that buffer. Of course, here I mean s1. And then you just simply increase I. Here I can also say break, okay? So I say write and then just exit from this internal loop, go back to the external one. And then here I just need to increase s1. And I would say that the naive implementation is almost here, you see? So I say, until I have a char pointed by the pointer s1, refresh I to 0, and then just check if the char pointed by s1 and s2 are equal. In the case they are equal, you just write, and then you just break. So you come back here and you keep going on, okay? So you increase s1 and keep going on. Let's try to check how this program works. So I'm gonna compile, for example, hello, this fancy string. What is going to happen? Hello. Here, you see the problem. I have 2 times the same char that is repeated. I don't want that. I want only the chars that appear in string 1 that are also in string 2 written in the standard output in the same order in which we found them. I don't want repetitions here. I don't need this information. If I have 3 hello here or more, look what happens. I don't want all of that. What can I do? Well, I need to stock the chars that I have already used, right? So I need a cache. I need a memory in which I can say, hey, I have already written in the standard output that specific char. Don't use it again. So I'm going to create a little cache. Actually, it's a simple space in memory. We can use an array, right? We can use another simple array to store all the chars that we have used. So let's create this cache. Here I'm going to say char v stands for vector with how many bytes? Well, I can use 128, which are all the chars available possible, even though this is too much. Nonetheless, it's a little memory for a modern computer. So I create my vector, and of course I initialize everything to 0, otherwise I'm going to have garbage value inside my array. This is an initialization, my friend. Pay attention here. When you do something like that, basically what's happening underneath the hood, you have a loop that is zeroing all the bytes of this vector. Initialization is qualitatively different from assignment. That's important. So if you have any doubts, just search for initialization array. Now I have my cache, and every time I stumble upon a char which is the same, what do? I say, if the char is the same, and the char is not already in my cache, so I say not in cache. Of course, is a function that I have to create. And I give as an input v, namely the array, and the char, so at s1. So in the case the char is equal and is not in the cache of all the chars that have already been written, you write it, and then what do? Well, you need to save in the cache that specific char. So you say v in position. What position? Well, you need a cursor, right? We're going to create immediately. So we're going to do int cache cursor to make extremely clear what is this stuff. Here I say cache cursor is equal to 0. So inside v cache cursor with the postfix increment, I assign what? I assign the char, okay? So I assign at s1. Cool, that's the operation. Now we're gonna very briefly implement the in-cache function. So it's gonna return a Boolean value. So I'm gonna include std Boolean, okay? So I can use the Boolean values. So bool in cache, taking as an input what? Here I give as an input an array, which is this one, right? But there some murky stuff that is happening when you pass an array to a function. Essentially, when you pass an array to a function, it's going to decay, as we say in jargon, to a pointer. So here I can simply write char star v, but I can also write like that to make extremely clear that this function is manipulating an array. But that's the same thing. At the end of the day, I'm working with a pointer. So char v array, that's why I don't need to specify any value, because it is not important, it is not necessary. This is a pointer, and then I give the char c. Okay, is in cache. What do I do here? I say while at v, so until I have a value which is different from 0, you go on and you check if at v is equal to c. What do? You return false, okay, because you stumbled upon a char which is the same, and then you just increase v. Easy peasy. You can do that because here I have a pointer. I don't have anymore an array. On the contrary, what do? You return false because you haven't stumbled upon a char which is the same. That's it. That's a function. So I have this function that is checking is the char inside my little cache. And I think I'm done with that. Let's try to launch the code. So again, I'm going to compile and launch. Not working. What happened? Here I got everything wrong. I need to make it false, and here I need to make it true. So here I stumble upon a char which is in the cache. Let's try again. Let's relaunch. And this time, as you can see, it works, right? Get only one repetition. Easy. It's very useful, in my opinion, to check all the stupid mistakes that I'm doing while I'm coding, like this one, to write here false, because that's what happens in reality. You always do these kind of stupid mistakes, and that's it when you code. So you have this function that is checking if a char is inside my little cache. So to understand what happens here when I pass the array, and here I get my array, which in reality it is just a pointer, you have to search for array decay into pointer. So you have to Google array decay into pointer and try to understand what is going on. These videos are just practical based, so I'm not gonna spend so much time in theory. I made a course about C if you want to check it out. Maybe I've already explained this idea. Here you have to understand initialization versus assignment. Here everything is pretty simple, right? Nothing really fancy to understand. And that's it. That's the code. Perfect. Write a function that determines if a given number is a power of true. This function returns 1 if the given number is a power of true, otherwise it returns 0. Pretty simple. So vim main.c, I'm gonna include stdio.h, then int main, int argument counter, char star argument vector. Perfect. There we are. I need function to determine if the number is power of true. Printf the number is a power of true. I'm gonna use command line arguments. Let's see if atoi of the number argument vector in position 1. So I need to include here the standard library, right, to use the atoi function. Let's say power true. As an input, I give the atoi. You print else, print nope. Okay, now we have to implement the power of true. Power of true is gonna return a boolean, right? So I'm gonna include a boolean. Okay, so standard boolean. So bool power of true that takes as an input an integer. How do I do that? Well, if a number is a power of true, it's fairly straightforward. What is a power at the end of the day? Power is multiplying the same number over and over again by itself, right? 2 to the power of 8 is multiplying 2 8 times. So I can say while n is major than 1, okay? So while n is major than 1 from 2 on, even though even 1 can be a power of 1 because 2 to the 0 is 1. But I'm gonna do like that. So and here I can say if n modulo 2. What is the expression about? Well, I'm saying if there is a reminder when I get a division of 2, for example, 2 modulo 2 gets me 0, okay? That's a power. 4 modulo 2 I get 0, and I will understand how it works. I say if I have a reminder, return false. Means that it is not power of 2. Then I simply divide the number, divide it equal 2. So for example here, if I have the number 10 as an input, I have 10 modulo 2, I get 5. Okay, this is not gonna pass initially, but I get 5 then 5 modulo 2 is gonna give me a return, so I'm gonna get 0. If I get 6, for example, 6 is divisible by 2, so the first step I'm not gonna get here, but the second time I have 3, which is not clearly divisible by 2. You get the point here, the math. So I'm brute forcefully checking if the number modulo 2 is getting me a reminder. If I pass all these tests, I'm gonna return true. Okay, I think this is correct. Let's make something here. I'm gonna comment this one because I think it's not super useful. I prefer to do something like that. For in I will equal 0, I minor than 100, plus I. If power 2 of I, you print it, okay? So you just print when this is a power of 2. So let's make the number bigger. Let's say 5 billion, so I get all the values which are inside an int. Let's try to run this code if it's easy. And then I'm gonna launch. Okay, it seems to work. What happens here? With expression of type int, of course. Anyway, it still works even though I have a warning. As you can see, you have all the powers of 2 here. I have also 0, which is not correct. So at the very top, I'm gonna put if n is minor, of course, even negative numbers are not correct. So n equals 0, you return false. Becomes now it should work correctly. Here I just need to change this int to a long I. Now the comparison should be correct. And here I just changed this to a long D. Okay, let's launch again. This time it works correctly. As you can see, I have all the powers of true, so it seems that my power function is working correctly, right? It's not very fast, but it works. So this is a brute forcefully approach. It's not very elegant. Let me show you something better. Check carefully this image. We have a binary machine, as you perfectly know, so every power of true at its binary configuration has only one bit which is turned on, as you can see. Here I have 1, 2, 4, 8, 16, and so on. And as you clearly see, I have only one bit which is turned on, because of course this is a binary machine. I can exploit this property of the bytes to get the result I want. Now I'm gonna show you. You delete everything which is inside these curly braces, so you do di curly brace. And you say return, and this is a bitwise operator, n minus 1, okay? I just put this inside braces, is equal to 0, okay? And then of course, and n is major, right? It's major than 0. That's it. That's the operation I'm gonna do. Now I go out, I'm gonna compile and launch again. And as you can see, it works exactly like before. Now, the response to this riddle lies upon the byte configuration of every number in binary. So I leave you with this exercise. Try to understand what is going on with it code. Use ChatGPT, and overall it's very simple to understand what is going on. Right, that's it for this very long video. Enjoy, my friend. Thank you for watching.